And now, I am glad to welcome on stage Mr. Milenko Starcik, Head of Cybersecurity at VisionSpace, our sponsor for a talk entitled From Regulation to Resilience, Implementing EU Space Act Cybersecurity Requirements.
Thank you very much for the warm introduction. My name is Milenko Starcik. I'm currently heading the cybersecurity section at VisionSpace Technologies. We're a German company with branches also in Portugal and Spain. Let's see if I can get this started.
May I ask that you put the microphone right in front of you?
Yeah, I'm sorry. I need to go a bit closer, but now it starts. So the talk today is going to be about the regulations that are upcoming, especially the EU Space Act is what I want to talk a bit about, and implications for the future. For those that are wishing line by line, we are not going to do that. I'm sorry to disappoint you, especially because the current text is not set. And when the first edition, like the first version of the EU Space Act came out, the proposal, I think a lot of companies, especially in security, like ours, were quite excited because there were quite a number of items on the list, like penetration testing, training, and things that, of course, interest us quite a lot, and that also can cause a lot of problems for operators. But now with the latest edition, I think there was a bit of a setback in the perception with the latest edition, because a lot of these bullet points and items with hard requirements were actually moved out of it. So I think this created a lot of uncertainty, and it's still uncertain how it will look like in the end. So this will be a bit speculative, because there is no final regulation and we are still talking about it. But I think there are some lessons learned from the past regulation that has been pushed, like NIS2, CRA, and the gaps that exist. So this is what I'll focus on, is the things that we already know and what we can expect to happen. So the question is, how do we get this later to operations, and which actions can we already take now to prepare for that future? Especially under consideration that timelines in space industry, as everyone knows, are very long. So if you make a decision now, it will usually take a couple of years until it becomes actually operational. And the same is true with the different regulations that come out. Usually there's a period where you can adopt it. But especially for space organizations, I see that there is a big problem. Even if you have 1 or 2 years for adoption, this will likely not be enough for you to actually bring it into your operations. And I think this is where a lot of operators are also like facing some problems. So yeah, exactly. My point is that we already see some implications from NIS2 and the Cyber Resilience Act, and clear gaps that exist. There was last year, there was a conference where I attended and talked with someone from regulation, asking, okay, like who's responsible, like which regulation is covering in Germany currently, the space element. And there is currently no regulation covering it. And I think this is a pretty obvious gap. And this is also something that is outlined also in the current version of the EU Space Act, is that the space element will be covered, that the data link will be covered. And these are things that you can already anticipate now and prepare for. So yeah, what we see as a common pattern between the different versions is that there will be lifecycle-wide cybersecurity required for your missions. You need to apply cybersecurity at every lifecycle stage of your mission, from the early design, even from your mission concept. You need to take security into consideration when you design a mission, even though your mission designers might not like that. But there will be discussions needed with cybersecurity people to define the level of protection that will be required later, which was previously maybe not the case because they were just doing an Earth observation mission, but now it's suddenly a dual-use ISR mission that they are building, even though they just thought it might be civilian, but in the end the implications might be different. That there will be coverage across space and ground, because space element is still highly unregulated actually. Of course the launching country has responsibilities, But right now, there's very little regulation actually forcing people to do something. And as we know, usually if there's not really pressure, then there's also very little action taken unless it's operationally required. And that you will have to demonstrate that resilience with certification, with compliance, with auditing, with external testing. And these are things that are coming also for more restricted environments. I think we see that already happening now in the defense domain. This is already happening, but you don't see it externally. And also what is now classified as like critical infrastructure for space, like the Galileo program and everything. There's a lot of security requirements that already are active. And I think these are the kind of requirements that will also come more to private industry. And I think this is also what we saw also from the American side, a lot of pushbacks on these regulations, where there were a lot of comments made and pushbacks from commercial industry saying like, oh, this is way too much regulation. And this will actually hurt our operations if we have to implement this. The last thing is that there is already quite a lot of documentation out there on how to do security on ground and space properly for space systems. There are currently quite a lot of working groups active. For example, from the BSI, they have put up some very nice standards for ground and space segment. There's currently the ISO working group, also developing a standard for lifecycle-wide cybersecurity for space systems. And I think what the new version of the EU Space Act also hints is that you will have to comply with something like this. And there are, if you read these, there are very common patterns across these. And it's very close to what you'll have to do if you are now falling under NIS2 already, for example, or if you have the Cyber Resilience Act coming up. And you can assume that you need to integrate these things and close the gaps. If you are now lucky that you are maybe not affected, chances are very high that you will not be so lucky in a couple of years. So I think it's very important to prepare for that. So what basically our internal assumption is that NIS2 will affect us also as company, because we are a supplier in the space industry. And if you're a supplier, very likely you will be affected depending on your size or not. Now the EU Space Act says, okay, where NIS2 does not apply, this applies actually. So even if you don't fall under it, they might just say, okay, use the EU Space Act instead. And the rules are very, very similar. Then there is what is the default way to handle this is often the ISO certification. So that's also what we are doing internally. We've done ISO 27000 certification, and we are looking at the gaps that exist between what this does, what we have to integrate to be compliant with NIS2, what we have to do for the Cyber Resilience Act, also CRITIS regulation in Germany. So there's also some national regulation. And you have to look at the gaps. There is a nice note from the BSI published that I've linked on the gaps also between ISO and NIS2. And I think this is one of the big challenges, is that you have national regulations and you have the European regulations, and you need to see how well your current controls cover these. And this is what we'll see later also. One of the pain points currently in security engineering for space systems is that you have quite a lot of different regulations, and especially if you work cross borders, you will have to comply with different rules in Germany, Portugal, Spain. For us, for example, there's different rules. And if you work on a European level, that's something that is quite challenging if you have one organization that works in these different countries, or if you have customers in different countries that have different requirements. So there is a need to close a gap here. To see where the current state of the space ecosystem is in terms of security, we are currently running some workshops as part of the ESA security system engineering toolset that we're doing. I don't know, maybe someone here in the room participated one of the workshops we held. No. Okay, then you learn now about it. So ESA is currently running a project to develop a new system engineering tool. We are in a consortium with Starion, Airbus, and SpaceCube. And this will basically do system engineering and security engineering together. And for that, we are running workshops to get actually inputs from operators and also from regulatory bodies across Europe, as inputs for the tool to see which standards we need to implement, which mappings we need to provide, which threats you are facing, and also with what are the current pain points. And I think this is where we have an interactive part now in the presentation. So there should be a poll coming up on the app. Yeah, there should be a poll on the app.
There it goes. Biggest problem integrating security with space mission life cycle. I see it in the tab. I think our friends there.
Ah, perfect. So yeah, so the question is, what is currently your biggest problem? Because we have collected this from roughly 100 participants across different organizations already. And we've seen some pretty common patterns, but would be interested to see your views. Especially since it seems like none of you already participated, so would be very happy to take your inputs on what you see as the biggest pain points if you have to integrate this. Ah, perfect. Timeline's long, exactly. That's definitely...
Long timelines. And money.
Money is always important, especially when it comes to security. That's definitely a very good point.
Conflicting priorities. Fear. Design. Lack of design, maybe, or lack of money, or lack of timelines. Legacy. We got a good one.
Yeah, that's actually pretty nice participation. Oh, still growing. I think it's splitting words, so if you put white space, I think it splits it.
Money by expertise we now have.
Okay, I think we can close it here. So the things we have seen are pretty common patterns here. And I think this is also described in this word cloud. What I already mentioned is the timelines are a huge problem, especially if you add requirements for security. If you have to, for example, follow the ECSS standard, you will get like 20 additional documents you have to do over just one cycle of your system design, just in parallel to the existing documentation that you have to do. So there is like a huge pressure on the teams actually implementing this. The next problem we had is traceability, so actually going from your architecture over the risks to the requirements, to the controls that you have implemented, to the evidence, and connecting this in like a coherent workflow. It's still very much spreadsheet driven to this day, and it's very hard to iterate on this. So if there's like another iteration on the security cycle, it's very hard to work with the current tools that exist. Next is standards mapping. So, like I said, with the different legislations that exist, and also interoperability, because usually still the connection point is an Excel spreadsheet. If you're exchanging security information between, for example, teams, you will often work in spreadsheets, and that's just not the way how efficient this can be done. And the last point is like with the timelines, also like the life cycle assurance. So we have seen the pain points across all of the different phases of the missions. So you already have these pains when you start, and you will have them with every milestone and every iteration on your infrastructure, every change. You will have to go through this again, and there is very little automation right now. So what we basically say is that waiting is often the most expensive decision, because if you postpone this and you just start with this process without any automation, without any tools, you will just suffer through it until the end. And that's very expensive. You're wasting a lot of time and money, and your team burns out quite a lot just by going through hundreds of lines of spreadsheets with your risks and tracing them manually, copying it over to Word documents and everything. It's a huge pain, and that's the reality of most security engineers. What they are working with. That's usually what the job description doesn't say. So what we propose is basically a life cycle approach to this. So we have some part of this in the SSE toolset, but this is a slightly different version what we use internally. And what we propose is that you start with the mission context. So you first need to have a clear directory of your assets, also automated collection of assets. That's something that is also still very much missing in a lot of space infrastructure, is that you actually automatically map your infrastructure and be able to use that for your cybersecurity engineering. And that you also have a machine-readable form of your current controls that are in your infrastructure, because often infrastructure is shared between missions, between different parts, and that you already have an overview of which controls are actually already in place, because that's quite important when you start actually doing your security engineering, so you don't have to do everything over and over again. So next part is risk assessment. So based on your current state of the system, you need to see what actually the risks are for these elements under the conditions that you have. And after that, you take these risks that you see as a high priority and basically do control tailoring. And after you applied them, you need to do validation of the controls you've implemented and collect the evidence that you have. And then the cycle basically starts all over again. And it's important to see that this is not just based on, for example, milestones, but also if you have infrastructure changes, if you upgrade an important piece of software that brings in new requirements, new external systems, if you have new hardware coming into your system, if you see that there is like a significant change in your infrastructure, you need to do this all over again. It's not enough to just do this once and assume that the infrastructure doesn't change, because that's not what is real. Usually the infrastructure evolves, something breaks, you replace it maybe with a different vendor or something, and you suddenly need to update your controls because the management plane looks different, for example. You need to add a new system here, and then you also need to update your risk assessment. And that's something that is currently very much lacking in most organizations, is to have this continuous monitoring and actually reacting to these changes with a new cycle, because it's much too costly to do this all over again. So what we are proposing are some capabilities that are required that we are currently working on, and this is just a bit of an insight on what we are doing to address these problems, and where we think that this could be also like interesting for others to work in these areas, and what we also saw here actually at the conference. So first is the security engineering tools must evolve, and also the security practices must be higher. So the standards must be higher to what you apply when you design a mission. You saw a lot of PQC talks here already. We also have a small PQC project with the European Space Agency. We actually had the first 4S program project on PQC. So we are already in the final stages, so this is not a concept anymore, it actually works. And we currently do full SDLS integration with the latest version of the EGACC kernel 4.0, which actually brings SDLS already in the mission control system kernel. We're currently doing integration with that, and it's a certificate-based scalable PKI system with PQC key exchange. Next thing, what I already mentioned, is the risk assessment. So we've developed some automation tooling, so you can put in your architecture. This is an example from an open source mission control system, Cosmos. It's a bit grainy here. Where you can basically define your architecture in a machine-readable format, so you can also take that in from your actually asset monitoring, and then it uses the Sparta TTP framework to identify risks based on the technology types that you're using and the protocols, so the space-specific protocols that you're using. If the encryption is weak on these protocols, for example, you will get risks that you wouldn't get with other means, and also automated reporting generation. Next capability that we see that is currently missing is testing. So a lot of the teams are not really testing for security. There's maybe validation, IVV activities, there's different acceptance tests for actually the function of the software, but there's very little tests actually for security of the software that is deployed in operations. From mission control system over simulators, mission planning systems, very few of these systems have actually been tested for security or designed with security in mind. What we are doing on this is we offer penetration testing, but we also do open source analysis and publish a lot of the results to raise a bit the awareness that there are a lot of vulnerabilities in these systems, especially if they are untested. And this is what is the truth for a lot of the software that is currently deployed. This is like closed source software that no one ever looked at with like a mindset to actually try to break it, because we want it usually to work, and if you use it right, it works. But there's often, if there's automation tooling, for example, there's often ways to break it. And what we've seen now, there's a lot of hype about this Project Glasswing, for example, from Anthropic, where we see that these large LLMs are used to automatically find vulnerability in the systems. And there's a lot of fear around this, but I would say that a lot of the problems that are now in these systems can be solved with a lot easier means. Like, even if static analysis tools would be used consistently, a lot of the problems would be mitigated. And there's not an adversary coming to your infrastructure into the depth with an LLM usually. And if you have that, then you have different problems than your mission control system security probably. So yeah, we currently have 41 CVEs. We are still publishing. We are also using LLMs to now accelerate the process, but there is still, as we heard earlier, there's always a human in the loop because there's a very high false positive rate. And also what the people at the Anthropic and so on are often not telling is that there's a lot of false positives they are reporting, and you only see the ones that make it through the process and that are vetted and that are then fixed by humans. For example, the Firefox vulnerabilities that they have published were in the end not fixed by a Claude agent, they were fixed by humans, and that was also a statement from Mozilla that they made, that they had to vet all of this very carefully because there's a lot of garbage, even if you throw the most expensive systems at it. And again, this is one thing you have to put money on the table, because if you want to use this latest generation of systems to find vulnerabilities, it will cost you 1,000 euros a day, maybe 10,000 euros per day to run these large LLMs on the code base, because you have code bases of millions of lines of code, and that's huge context windows. So what we are basically doing is we first run static analysis, and we use this to triage some of the findings and accelerate the process to find the trust boundaries. But if you just throw an LLM blindly at it, you're burning a lot of money that you could also spend on a proper pen test. Next capability is training. I think that's very important to also bring the knowledge into the teams, so that not just there's an isolation between the security guys and the operations guys and the system engineers in the organization, but that everyone in the organization has a basic understanding of how to test the software for security. And for that we basically offered also before this conference a 2-day workshop, also offer that continuously now for onboard software, ground segment, digital radio, CI/CD, DevOps, because these are the things that are integrated and where actually everyone working on them needs to know at least something about the security of them. And last is again the fun part, it's documentation and document generation and how to manage all of these things that we talked about across the life cycle. And I mentioned the SSE toolset previously, which is trying to cover this. And that also comes with an integration with the NIST OSCAL system. So what we've built is basically an OSCAL Explorer where you can view and edit also artifacts that you can submit also to agencies if you want. So for example, there's also the BSI Grundschutzkatalog is also published in OSCAL format. So that's a machine-readable format where you can do your entire engineering life cycle. And yeah, we are currently developing tooling around that. So yeah, final takeaways is to integrate the regulation with the engineering and to keep the risk, controls, and evidence connected, and to validate the security early and also regularly, because it doesn't make sense to just do it every milestone, and to build the capabilities now and not just before the deadline exists. So the call to action is start now. And with that, I say thank you.
Thank you very much, Mr. Starcik. Well, time is almost up, but I think it's important to mention a bit of the timeline. This legislative initiative was developed and proposed by the European Commission in June the 25th, 2025, so last year. It was interesting you mentioned how you could beforehand, before the regulation is indeed adopted, start to adapt. There are many questions to be asked, I think, about how this regulation is shaped. We've heard a lot of speakers expressing their regrets, maybe that their interests are not well taken into account And you show us how the actors on the field can also anticipate the policy demand and requirements. So thank you very much for that. I wish we could also address one of the pillars that is part of this Space Act being resilience and sustainability. But we still have a day to go, and our next session is a panel on the EU space cyber regulatory landscape at 11. It is now time for the coffee break. I invite everyone to go to CYSAT booth to go further on the workshop you started to explain. And thank you very much. We can give you another round of applause, and we'll be back at 11.
Thank you.